the product rule using implicit differentiation in logarithms. So what I've went ahead and done is wrote y as f of x times g of x. And our goal is to show that y prime, the derivative of y, is the first times the derivative of the second plus the second times the derivative of the first. So we're going to start here, and what we're going to do, similar to my power rule video, if you've seen that, is we are going to take the natural log of both sides of this equation. Okay, so we started at y equals f of x times g of x, and now we have the natural log of y is equal to the natural log of f of x times g of x. Why did we do that? Well, the reason why we did that is, look inside here. So inside here, we have a product inside of the natural logarithm. We can use the properties of logs to split that up into the natural log of f of x plus the natural log of g of x. So let's go ahead and do that. So the right-hand side, by the properties of logs, is going to be the natural log of f of x plus the natural log g of x. Now we can take the derivative of both sides. We're also going to use the derivative part. Okay, so the derivative of the left-hand side, the derivative of the natural log of y, is going to be 1 over y. But since y is a function of x, we have to multiply by y prime. Okay, now the derivative of the natural log of f of x is going to be 1 over f of x. And by the chain rule, we got to multiply by the derivative of the inside. So the derivative of f of x is f prime of x. Similarly, the derivative of natural log of g of x is going to be 1 over g of x times the derivative of the inside, which is times the derivative of g of x, which is g prime of x. Okay, so all we did is we started off with y equals f of x times g of x. We took the natural log of both sides, and that allowed us to use properties of logs to split up the natural logs. And now we took the derivative of both sides using implicit differentiation and the chain rule. And we got this ugly mess right here. Well, what we can do now is we can multiply both sides by y, because our goal is to get y prime. So doing that, we're going to multiply both sides by y. We're going to get y prime. It's going to equal to, so we're going to multiply all this by y. So it's going to be y times f prime of x over f of x plus g prime of x over g of x. Now, this does not look like the product rule that we know and love. For one, we got quotients going on, and we also have a y involved, right? We don't want that y. We want just f of x's and g of x's. So how can we get rid of this y? Well, we originally defined y in the very beginning of the problem to be, so we defined y to be f of x times g of x. So down here, we can substitute for y. We can say y is f of x times g of x, because that's what we defined y to be. So it's going to be f of x times g of x. That's our y. And it's still multiplied by this mess right here. So let's okay. And finally, the last step, we can distribute f of x times g of x into the parentheses. So you'll notice that when we do that, we'll have the f of x will cancel out with this f of x in the first term, leaving us with just g of x times f prime of x. And similarly, the g of x here will cancel out with this g of x here, leaving us with just f of x times g prime of x. And there you have it. That is the product rule that we know and love. And we got there using natural logs and implicit differentiation, which I think is pretty cool.